Hello. So yesterday we have solved these two problems: palindrome partitioning and letter combinations of a phone number. So today we will solve n queens problem. Yesterday we have discussed what is a means n queen problem means. We have discussed its description. So basically, uh, uh, in one line I have explained that putting n queens on a n into n board so that no queen kills other queens. So that is a n queen problem, and I have replaced n with this 4. So putting 4 queens on a 4 into 4 board so that no queen kills other queen. So we have to return configurations. Basically we will be given with a n. So here n is 4, so we have to place 4 queens 1 2 3 4 into this 4 by 4 board, and so that these queens do not means cross each other or kill each other. I don't exactly know what in chess we call it. So we have to return all the configurations in which we can put n queens. So our n can be 9. So basically our chessboard can be 9 into 9 chessboard. So how we can implement backtracking here is basically backtracking is choosing a path and trying it, and then choosing another path. So we will try to place a queen at every position and we'll check if that works. So let's start implementing. So we have to how will be our output format look like. So it will look like a n into n array, where n into n array of a string, and where q will represent a queen and dot will represent a box, empty cell. So we have to return array of array. So what will our initial configuration will look like. So we have to return a list of string. So first string, second string, third string, fourth string. So our initial configuration will look like let's call it a board. So our board initially will look like when we haven't placed any queen. New array list. So we need a string. We need n strings. Let's call it a current row. It will be empty, and we need to put n dots. So initially we will have nothing, and we will put the current row into our board. So list.add current row. So we have made our board. or what we can do is we can call it into a separate function where we can call the function as create board and return that board at the end. Something like public list of string create board, and we need to pass n in that board, and we can at the end return this board. And instead of doing all this stuff, we can call our create board function and pass the n. So this function will return us the empty board. So now we have our board, and on this board we need to place n queens. So we will call our, let's initialize our answer variable. So answer will look like a list of boards. So we will return all the boards, means configuration of the all the boards. So list of board, which will be our answer, or we can call it configs is equals to new array list, and at the end we need to return this config. So we will call our utility function where we will be generating all the valid configurations. So we will pass our n, that we need to place n queens, and we will call our empty board, and we will pass our configs array, configs list. So public void utility and and let's initialize list of string board list and list of string configs. Okay, so whenever our n becomes 0, means this means we have placed all the queens, so we can return as we don't need to return, means we have a valid configuration, and we can add that configs dot add that board into our configurations part. So how we will gonna put a queen? Okay, so we also, let's say initially we have 0 queens. We need this variable, means the size of the board, we need size of the board. So initially we have int queens will represent number of queens we have means put up on the board. So whenever our queens become equal to n, then we can say that our queens are added to the all queens are safely added to the board, and we can add that board to our configurations. So one thing, one observation here is that in each row we will place only one queen, means on same row we cannot place two queens, because surely that queen will cross each other when we place them in same row. So we will use this idea that we can only place a single queen on a row. So initially we are at 0th row, means initially we are at the 0th row, so we will iterate 0th row int I equals to 0, I less than n, means all these cells of the 0th row, and we will try to put a queen at this position. Okay, suppose we want to put our queen at 0th row, and this is the column, means on which column we want to place. Means we want to place our queen at row, we can also call it a row. So whenever row plus 1 becomes equal to n, then we can say row becomes equal to n. We can say we have put all the queens on the board. So we at position, row and column. So we need to verify if it's a valid position. Suppose we have put our first queen on this position, and now we are our row is 1, so we want to put and column is 0, means we want to put a queen at this position. So we need to validate this point, means whether we can put a queen here or not. So we will move in all the parallel direction, means left, right, down and up, and all the diagonal positions, to verify that if we can place queen at this position. So let's say we have a function if valid, means is valid position. Let's say call this function is valid position. So this function will verify if a particular position is valid to put a queen or not. So is valid position row, column and in the board. If it's the valid position in the board, then what we can do is we can modify our board, means modify board. So how we can first we will modify board, and then we call our utility function with we will move to next row and n and board and configs, and then we will undo modification. Okay, wait a second please. Hello, एक second. 379296 379296 हो गया. कोई नहीं, ठीक है, ओके भाई. Okay, so we will modify our board. So we will first take a string take the string at board dot get at row position. We have now string. We need to modify this string. In this string at column position we need to add a queen. So our s becomes s dot substring 0 to column. So this will take a substring of s from 0 to column -1 plus a queen and plus s dot substring let's call this current and initialize another string, modified string. So s dot substring start from column +1 position. So we are removing character at column position and adding q in that position. Call -1 and length of the string will be n. So n. So this is our modified string. And now what we will do, we will replace our string at row position by our modified position. So let's see if this is a correct function. Replace a value at index in list in Java. Set function we need. So what we need set at rowth position as modified index. So after that we will undo our modification. So how we will undo our modification? We will put current, means previously there was a current string, so we will replace, what we will do, board dot set at rowth position, we will replace it with current string. So that will work. So instead of s we need to take current. Now we need to implement our is valid position, means if row, column, cell is a valid position in board to put a queen. Okay, so let's implement is valid position. Let's make these functions private. We will not allow other classes to access our functions. So private boolean is valid position int row int column and list of string board. So we will not check our current row if current row has any queen, because we are only putting one queen in every row and we are moving then to next row. So we will not check in our current row. Instead we will check in column and diagonals whether there is queen present in uh, this column or in these diagonals. So we will first check in column. So we are trying to put queen in this column. So we will start from I equals to 0, I less than n, I plus plus. So we don't have n here, we haven't passed n here, so we can also pass n. So we will check this column. So if board dot get I means we have chosen the ith row, and in that ith row we will check this column, character at this column. If this is equal to q, then we need to return false, that we can't place a queen as there is already a queen in this column. So we have checked column and we will not check row because we are putting a single queen in every row. So now we need to check diagonal. Okay, so suppose we are at this position. So we need to check these diagonals and these diagonals. So let's say to go to this diagonal which is in right, what we need to do is we need to increment both row and column. Okay, so first we will check this diagonal. We can have four diagonals. One is which is in the bottom right, one which is on the bottom left, one which is on the top left, one which is on the top right. So diagonals, first we will check bottom right. So we need to do +1 into row and +1 into column. So initially let's say our I position is row and j position is column. So while our I position, so here we have to check our I is smaller than n and j is also smaller than n, means these values don't don't cross our board. So I should be smaller than n, j smaller than n. So if our board dot get, we will use this same function is queen, then we will return false and we will add increment our I and increment our j. Again we will use these variables. Now we will go to position, let's say bottom left. So moving to bottom left, what we need to do is we need to increment a row but decrement a column. So we are incrementing our we are moving downward, so we are incrementing our row. So we need to make sure that our row is smaller than n, but we are decrementing our column, so we should maintain it should be greater than 0, and we will add the same check. Okay, so not same check, we need to decrement our column, so we will decrement our column. Now we will check our, let's say we have this queen, so we need to check this diagonal. This will be top right diagonal. So top right diagonal, what we need to in top right diagonal, we are incrementing our column, means we are going to next column, but we are going previous to our row, so we are decrementing row and incrementing column. So we will use this same code, but what we need to do is we need to decrement our row but increment our column. Now the fourth case remaining, which is, suppose we are at this queen and we need to check, we can the what we call it top left column. So in top left column we are going one row behind and also one column behind, so we are decrementing both. So we will use this code, and as we are decrementing both, so we need to check if both are greater than 0, and here we were decrementing row, so we need to make sure row is greater than equal to 0, and j, we are incrementing j and j should be smaller than n. So that's, these are the check we need to add. I think there must be a smaller means a way where which we can do it in few lines. So I think in order to do it in few lines, we can reach to the top of the diagonal, means at the end of the diagonal we can reach. Suppose we are at this position and we want to find top of this diagonal, means we want to find this position. So this position will be, so this is my row projection, this is my column projection. And we need to find this position. First let's see if this works, then we can optimize our solution accordingly. So let's do a sum up quickly. We have created a board, empty board. We have called our create board function with n. So this is our create board function. We have initially putting all the dots, and we are returning our board. After that we are initializing our answer configurations. Then we are calling utility function whenever our row reaches n. Initially our row is 0, so we will add to configurations. Otherwise we will iterate all the columns of that row and try to put a queen at that position. We will check if that position is valid, means checking diagonally and column wise that if there is a queen at that position or not. So instead of column we will put here as j. If our position comes to valid, then we will we will get that current cell, current row. So this is our current row, and we will modify our current row by putting a queen at column position, this position, and then we will add that modified to our board and call our utility function. After calling this utility function, well, when this call ends, we will remove that, we will reset it to current. So let's run this function. Okay, at the end when all the checks pass, we can return true. Okay, we are getting some error. We are getting all dots in both cases, so I think our validation function is not returning true. That is why we are not getting in this loop. This function looks good. Let's see if we are getting till here or not. Means let's see if any of the position we are getting as valid or not. Okay, so there's some issue with the modification, I think. Let's see what we are. getting as a modified string and current string. So we are getting correct our modified string and current string. So where we are having issue is our board not getting modified. Or we need to add a new list here. New array list means we need to add a copy of our board, I think. Okay. I think this will work. Let's submit this. Okay, we have a submission. So let's go on description part and see if how we can make this valid function is valid position function smaller. So we need some method to decide the end point of the diagonal, means then we have not have to do many iterations, means 4 iterations, then we will then doing 2 iterations will be sufficient. Means we for this index we need to find this value. Means if row is greater, then this box will be on rows side. If both are equal for this case, then it will on be 0 0 position. And if column is greater, means if value of column is greater, means suppose if which case, this case, for this case if column is greater, then it will be on column side. Means the minimum value will be this. So let's say initially our I is 0 and j is 0. So if our column is smaller than row, and we will have a condition else if our row is smaller than column. In the case of equal, we will have both 0. So bottom right, means bottom right and top left. This will be removed. If our row is smaller, for this case, let's say our queen is here, so row is 4, 3 and column is 2. So what this our position becomes, what this position becomes means I becomes 3 from last. Means n minus column, means here n is 4, 3, 3 minus 2, 1, 0, 1. Okay. Otherwise j would become n minus column. Let's see if this works. Okay, this is not working. N minus row, not column. Okay, this case is not working. Suppose we are at here position. We are here. This is 1. Means row is 1, column is 0, 1, 2, 3. So row is smaller. Then j will become, I will become 0. Okay, which is 0, and j will become n minus, n is 4, 4 minus 1, 4 minus 1. I think we need to add a plus 1 here. Four minus 1 is 3. 2, 3. Okay, still we are not getting. Zero, 1, 2, 3. So this is 3. Means if in the case row equals to 1 and column equals to 3, we need our I as 0 and j as 2. And our n is 4. So what we are doing 4 minus 1 . 4 minus 1 is 3. 4 minus 1 is 4. 4 minus 1 is 3. 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 4 min which is 3, and then we are doing plus 1. We need to do minus 1. Okay, we are doing 4 minus 1, which is 3. 3 minus 1 is 2. So making j as 2. But if we are at this position, our row will be 3, column will be 2. So our column will be smaller than row. And we need I as 1, j as 0. So our j will remain 0 and I will become 4 minus 2, which is 2. 2 minus 1, 1. 1. Then why we are getting this issue? Let's ask GPT. GPT also not able to find the issue. GPT is moving to above position. Okay, so I think we did not need to change our previous approach. There should be, must be better solutions. So this is a validate function. Don't know how this is working, so this is correct approach we are using. So that is it for today. We have completed our backtracking part. So tomorrow we will start with tries. So I think we have done half of the questions. Yeah, we have done half of this list. I think we will be able to solve rest in another 20 20 25 days or earlier.